Hello, everybody. Hey, Mr. McKee here. We're going to go over motion number 6. Now, a lot of you guys are having trouble going over this. So there's kind of two ways to look at it. One, you can just kind of follow along and identify all of the variables that are listed on the left-hand side, plug those in, and then essentially try to find each of those things by using the appropriate equation. The other way to do it is find the appropriate equation and then find the information that you're looking for. All right. So we're probably going to do a little bit of a combination of this. So now number one, it says a car traveling at 15 meters per second decelerates steadily, comes to a stop in 5 seconds. So our final velocity is 0. Our initial velocity is 15. Our time is equal to 5. So now it's kind of asking you for the delta V there, and that's going to be V final minus V initial, which is going to be 0 minus 0 minus 15. Now, you guys, we know the acceleration is delta V over T, so we're going to get negative 15 over 5, and our acceleration is negative 3 meters per second squared. All right. So that is our acceleration. That is for number one. All right. So if we're going for number two, a roller coaster at the top of the hill has an initial velocity of 12. It has a final velocity of 26, and that takes a matter of 2 seconds for that to do that. Now, you guys, it's asking for the delta V, which, as we already know, is going to be V final minus V original. So this is going to be 26 minus 12, which is equal to 14 meters per second. That is our delta V. Again, you guys, we're looking for acceleration. Acceleration is delta V over T, which is 14 divided by 2. So that's going to be an acceleration of positive 7 meters per second squared. All right, that is question number 2. Switching over to equation number 3, starting from rest, a moped has acceleration of 5. It travels for 4 seconds. What is the moped's final speed? Okay, so we're going to have our initial velocity is 0, our acceleration is 5, and our time is equal to 4. Final velocity is equal to our original velocity plus AT, one of your equations. Okay, so we can say 0 plus 5 times 4, and that's going to be a final velocity of 20 meters per second. Okay, that is the answer to number 3. Okay, I'm sorry about the glare here. Okay, but I'm not sure I can do much about that. Okay, you guys, if we go on to problem number 4, you guys, we've got a hand-built cart, starts from rest, accelerates downward at 0.5. It takes the cart 10 seconds to reach the bottom. So again, we have an original velocity of 0. We're going to have an acceleration of 0.5, and we're going to have a time of 10 seconds. You guys, we're looking for the final velocity. It's the same equation. V final is equal to V initial plus AT. We get 0 plus 0.5 times 10. 5 meters per second is equal to our final velocity. Okay, question number 5. A roller coaster is moving at 30 meters per second at the bottom. 4 seconds later, it reaches the top of the hill at 10. So we're going to have an initial velocity of 30, and we're going to have a final velocity of 10. So our change in velocity is going to be V final minus V original. That is going to equal to 10 minus 30, which is equal to negative 20 meters per second. You guys, we also have a time of 4 seconds. Okay. We are going to say acceleration is equal to delta v over t, which is going to be negative 20 divided by 4, which is equal to negative 5 meters per second squared. And that is our answer to question number 5. Okay, I am going to pause this and erase something. All right, ladies and gentlemen, here is problem number 6. Okay, from a stop, so we have an initial velocity that's equal to 0. A skateboarder covers a distance of 230 meters in a time of 46 seconds. Now, ultimately, you guys were looking for the acceleration, but we know that the acceleration is going to be equal to the change in velocity over time. So we're kind of headed there. So we know that the average velocity, and this is what our next thing is asking for, is equal to distance divided by time. So we're going to have 230 divided by 46, and we're going to get an average velocity of 5 meters per second. 5 meters per second. Okay, now we want to know the final velocity, and we know that final velocity is equal to 2 times the average velocity minus the original velocity. So we're going to have 2 times 5 minus 0. So our V final is equal to 10. And now we can get our acceleration, which is delta V over t. So our delta V is going to be V final minus V original, which is going to be 10 minus 0, which is going to be equal to 10 meters per second divided by our time of 46 seconds, and that's going to equal to 0.217 meters per second squared. We can round that to 0.22 meters per second squared. So that is going to be our acceleration for problem number 6. I'm going to set it for. All right, problem number 7. It takes 4 seconds for it to come to a stop, so our time is equal to 4 seconds. Our final velocity is equal to 0. We covered a distance of 15 meters. Okay, so now we can calculate the average velocity, which is distance divided by time. Okay, our distance is 15. Our time is 4 seconds. So that means we're going to get 3.75 meters per second. Okay, that's our average velocity, 3.75 meters per second. Okay, now we still want the car's acceleration, and we know acceleration is delta V over t. So we want to calculate our final velocity, okay? We want to calculate our original velocity, which is 2 times our average velocity minus our final velocity. So we already know that our average velocity is 3.75 times 2 minus 0 is going to give us 7.5. So our original velocity is 7.5 meters per second. So our delta velocity is going to be V final minus V original, which is going to be, 0 minus 7.5, which is negative 7.5. We're going to bring that up there, negative 7.5 divided by our time, which is 4 seconds. And when we calculate that, we're going to get negative 1.9 meters per second squared. Now, it is negative 0.875. We're just rounding to negative 1.9. All right, that is problem number 7. Getting set up for problem number 8. All right, you guys, we're back with problem number 8. Now, problem number 8 is telling us a runner has an original velocity of 6. So an original velocity of 6 meters per second. And he slows down to 0. So we have a final velocity of 0. And the runner is covering a distance of 12 meters. And we want to know how long it takes. Okay, so we know that time is going to be distance divided by average velocity. So we have the distance. We want to cover the average velocity. So average velocity is going to be equal to v final plus v original divided by 2. So that's going to be 6 plus 0 divided by 2. So our average velocity is 3 meters per second, okay? So now we can cover a distance of 12 meters at an average velocity of 3 meters per second, and that's going to give us a time that's equal to 4 seconds. All right, so problem number 9. A kangaroo with an original velocity of 3 accelerates at 1 meter per second for 2 seconds. What distance will the kangaroo travel? Okay, so we're going to have an original velocity that's equal to 3, an acceleration that's equal to 1, and a time that's equal to 2. So our final velocity is equal to our original velocity plus AT. So we're going to have 3 plus 1 times 2 gives us a final velocity of 5 meters per second. All right, so now we want to calculate the velocity average, okay? And we can go v final plus v original divided by 2, which is going to be 5 plus 3 divided by 2. That's equal to 4 meters per second. And we now can go distance is equal to average velocity times time. So we have an average velocity of 4 meters per second, and we have a time of 2 seconds. We multiply that, we're going to get 8 meters is equal to our distance. Okay, setting up for our last problem. All right, and finally, problem number 10. A rocket at rest accelerates at a rate of 190 meters per second squared for 2.4. What's the final velocity? Okay, so we know our initial velocity is 0. We know our acceleration is 190, and we know our time is equal to 2.4 seconds. And we can calculate v final is equal to v original plus AT. So we know that that is 0, so we can just put 190 times 2.4, and we're going to get 456 meters per second. That's equal to our final velocity. Now, you guys, as you're watching this, you want to make sure that you can do each problem. That means you can rewind and go over and over it so you can do it. Don't just rely on copying this. You need to go through it step by step. All right, thanks, and we'll talk to you soon.